Do you remember what you were doing on March 10th, 2016? It sounds like a random date, but something happened that day that permanently changed how the world thinks about artificial intelligence. In a quiet room in Seoul, South Korea, two opponents sat across from each other to play the ancient board game of Go. On one side was Lee Sedol, one of the greatest Go players in history, a man who had won 18 international titles and was considered a living legend of the game. On the other side was not a human being, it was a computer program called AlphaGo, built by a British AI company called DeepMind, which had recently been acquired by Google. Go is widely considered the most complex strategy board game ever created. Unlike chess, the number of possible moves in a single game is so astronomically large that experts say it exceeds the number of atoms in the observable universe. For decades, the consensus was clear: no machine could ever beat a human master at Go, and yet AlphaGo defeated Lee Sedol in the first game, but it was game 2 that truly shocked the world. Midway through the match, AlphaGo placed a stone on the board in a position that no professional player would normally consider. The commentators went silent. Lee Sedol left the room for 15 minutes. That single move, later known as Move 37, was not a mistake. It was a glimpse into a completely new way of thinking about the game, a strategy that no human had discovered in over 2,000 years of playing Go. To the West, this was an impressive milestone. To China, it was a wake-up call that changed everything. Chinese scientists and policymakers watched those matches and immediately understood the implications. Within a year, the Chinese government released a national strategy declaring artificial intelligence a top priority with one explicit goal: to become the world leader in AI by the year 2030. What followed over the next decade is one of the most remarkable stories in the history of technology. To understand how China got this good at AI this fast, you first need to understand what AI actually is, because AI is not one single thing. It is a stack of technologies layered on top of each other, and the global race between the United States and China is happening simultaneously across every single layer of that stack. At the very bottom is the hardware layer. This is the physical foundation. Follows the data centers, the cooling systems, and most importantly, the microchips. These chips are carved out of a material called silicon, a semiconductor that sits between a conductor and an insulator. Engineers can control silicon to flip billions of microscopic electrical switches on and off billions of times per second, and those switches create the language computers understand. The most important chip in AI right now is called a GPU, originally designed to render video game graphics, but later discovered to be perfect for the massive mathematical calculations AI systems require. The latest GPU architectures contain hundreds of billions of microscopic switches and cost between $30,000 and $40,000 each. Training a large AI model requires tens of thousands of them running simultaneously inside billion-dollar data centers. Here is where things become deeply political. The company that dominates GPU production is nvidia, and nvidia does not manufacture its own chips. It designs them and sends those blueprints to be built by one company in Taiwan called tsmc, which controls roughly 90% of the global market for the most advanced chips. Under US law, any company using American technology is banned from selling these advanced chips to China, and since tsmc relies heavily on American software, patents, and machinery, China is effectively locked out. This is the wall China ran into. They could build the data centers, they could pour the concrete and install the cooling systems. But getting the actual engine to power those systems was a completely different problem. Most Western experts assumed that was the end of China's AI ambitions. They were wrong. What China did next sits in the second layer of the stack, which is the model layer. This is where the actual brain of modern AI lives, and this is where China proved it could compete. Chinese engineers, led by a company called deepseek, were forced to work with older, less powerful chips that had been stockpiled before the export bans. Instead of complaining about the limitation, they became obsessed with efficiency. They asked a question that well-funded American companies rarely had to ask: how do we get better results from weaker hardware? The answer came through two major breakthroughs. The first was pushing an architecture called mixture of experts to an extreme level. Instead of activating the entire AI brain for every question, deepseek divided the model into 256 tiny specialized clusters of neurons. When you ask a math question, only 8 of those clusters activate. The rest stay completely idle. This reduced computing costs dramatically. The second breakthrough was a memory compression technique they invented called multi-head latent attention. When an AI is having a long conversation, it has to hold the context of everything said so far in its short-term memory. Normally, this consumes enormous computing power. deepseek's technique shrinks that memory footprint by over 90%, allowing the model to stay focused while using a fraction of the resources. The result was stunning. deepseek built a world-class AI model for reportedly under $6 million, while American companies were spending hundreds of millions on similar systems. They then made it open source, releasing the entire blueprint for free to researchers and developers worldwide. Overnight, the model became a platform. Thousands of engineers around the world began building on top of it, accelerating progress faster than any single company could manage alone. The Western tech world called it a Sputnik moment, a sudden reminder that a rival had caught up far faster than expected through a completely different path. But the story does not stop there, because above the model layer sits the most powerful layer of all, the data layer. An AI model begins as an empty brain. It only becomes intelligent through exposure to massive amounts of human knowledge and behavior. For years, American companies trained their models by scraping text from the entire internet, books, articles, research papers, and social media posts. But as of 2026, they have essentially run out of clean, high-quality data. Whatever was available on the open internet has already been collected, and much of it is now locked behind copyright lawsuits and privacy regulations. China sits in a fundamentally different position. Companies like ByteDance, which owns both Douyin and TikTok, operate what are arguably the most efficient video data pipelines ever built. Every single day, hundreds of millions of Chinese Chinese users upload ultra-high-definition videos covering every conceivable aspect of human life. And because ByteDance owns the platform, it has direct access to the original uncompressed files along with precise engagement data, knowing exactly which frame a viewer lost interest and swiped away. This is why a Chinese AI video tool called ByteDance is outperforming American competitors like OpenAI's Sora. When ByteDance generates a video of someone walking through a puddle, the water splashes correctly, the reflection matches the environment, and the sound syncs perfectly with the visual. That level of physical realism comes from training on an enormous volume of perfectly labeled real-world video, a resource that American companies simply cannot match. ByteDance's AI chatbot called Dubao has already surpassed DeepSeek in users and currently holds the #1 position among AI chatbots in China, largely because it combines strong reasoning with the ability to generate images, video, and realistic voice all in one place. So where does this leave us? China was blocked from the hardware. It innovated at the model layer. It holds a structural data advantage at the consumer layer, and it has a population of 1.4 billion people constantly feeding its systems with real-world information. The United States still leads in raw computing power and in the development of the most advanced chip architectures, but the gap is closing faster than most experts predicted, and the battlefield keeps shifting. What started with a board game in Seoul in 2016 has become the most consequential technological rivalry in modern history, and the outcome of that rivalry will shape almost everything about the world that comes next.